presi dal titolo Modeling and Dynamic Behavior Analysis of Hydrogen Electrochemical Compressor. I relatori sono il professore Caponnetto, la professoressa Sibiglia e l'ingegnere Matera. Presenta la tesi il professore Caponnetto.
Buongiorno, Enrico ha sviluppato la tesi essenzialmente alla CNR di Messina, all'Istituto di Tecnologia Avanzata per l'Energia. Ha lavorato, ha realizzato il sistema, hanno realizzato un sistema di misura e hanno preso le misure che sono la base per il modello del compressore. Il compressore non è il solito compressore meccanico che siamo abituati a vedere, ma è un compressore di idrogeno. Adesso vi dirò lui come è fatto. Alla fine abbiamo ottenuto un modello che è il punto di partenza poi per controllarlo e adesso vediamo i risultati.
Thank you for the introduction. So this presentation is divided into 5 parts: a brief introduction on the system, the experimental setup, the measurements, dynamic analysis, and at the end the conclusion and future developments. So the HC is an electrochemical hydrogen compressor where hydrogen is supplied to the anode and compressed gas is collected to the cathode. The main applications for these devices are the hydrogen compression for storage, hydrogen purification, hydrogen separation, or the circulation of hydrogen in a fuel cell tank. In the figure is represented the structure, so it is mainly composed of several layers. The layer, which is the innermost layer, allows the separation of the hydrogen into protons and electrons. Then the gasket prevents the leaking of gas inside the cell. The anode and the cathode flow field plates allow the conduction, the electrical conduction between the two plates, and the end plates have a structural function. So the working principle is mainly based on 2 reactions: an oxidation at the cathode and a reduction at the anode. So the oxidations separate the low pressure hydrogen into ions and electrons. The ions pass through the membrane, instead the electrons pass through the external circuit. So at the cathode the reduction occurs and the high pressure hydrogen is reformed. Here is showed the experimental setup used for the measurements. In particular, the hydrogen is connected to the cell between a pressure regulator, a mass flow controller, and a bubble humidifier. Talking about the power supply, the devices used are 2: Autolab and Keysight technology. The main differences between these 2 devices are that the Autolab can reach a maximum current of 20 ampere with the booster module. Instead, the Keysight technology power supply can work with higher current. So for low current was preferred the Autolab, for the other application the Keysight technology power supply. Autolab has their own software, which is called Nova. Instead, the Keysight technology power supply was not equipped with their own software, so part of the work was dedicated to realization of LabVIEW software. In particular, this software is able to perform 6 procedures: a polarization curve with variable step or fixed step, both in voltage or current mode, and the time test. The breaking phase was necessary before to start with the measurements. In particular, it consists of 10 polarization curves, which are shown in the figures, the first one and the last one. In the slide is summarized the main parameters measured, and they are the OCB 0.99 volt, the impedance 5.6 milliohm, the current which is 25 ampere, and the VREF which is 0.58 volt. So the operating conditions for the first time test are the following: the temperature of the cell humidified end of the tape, 60 degrees, the beta parameter, which is the ratio between the pressure have the cathode as pressure, the pressure at the anode is 1, and then the flux at the anode is 260 SCCM, and the voltage imposed for the time test is 0.01. So, from the result, it was clear and unexpected behavior, because this oscillation was not expected by the mathematical model. So this represented a big issue to solve, and so a first time step was to investigate the possible causes. So I tried to change the current range, in particular imposing a different value for the voltage, 0.1 and 0.25, but the phenomenon persists. So I tried to change also the pressure ratio, the beta parameter, imposing a beta equal 2 for the first test, equal 4 for the second test, but also in this case the current fluctuations persist. So the last attempt regards the water management. In particular, the cause of this current fluctuation can be due to the water management of the cell. In particular, the increasing of the impedance corresponds to the membrane deviations. So the idea was to turn the cell in horizontal position using these two legs and to supply artificially the water to the cathode side. Unfortunately, also in this case, the current fluctuations are evident, so the possible causes is not individuated, but the first analysis was done. The second part of the research activity was based on a dynamic analysis of the system. In particular, I tried to find some chaotic features of the system. The signal used as a time windows extended to 29,000 seconds to obtain a better results. So I used the embedding technique, where the basic idea is to make copies of the signal with fixed time delays and consider this delayed value as coordinates of the phase space retrieved from data. In particular, tau is the lag, the time delay, instead m is the embedding dimension. So the MATLAB algorithm is based on different criteria to optimize the value of m, the embedding dimension, and tau, the lag. So the criteria for the embedding dimension are the fault's nearest neighbors, or alternatively the simplex geometry. Instead, for tau, they are the first zero of the autocorrelation function, or the first local minimum of the mutual information. In this table are summarized all the largest Lyapunov exponent calculated by the algorithm, and they are all positive. So this is a first evidence of the sensitivity of the system to the initial condition, which is a main feature of the chaotic system. Then the phase space was reconstructed both in 2D and in 3 dimensions. So in conclusion, the research activity showed an expected behavior of the EHC that is not known actually. First analysis demonstrated that the phenomenon does not depend on beta, current range, or water management. Then dynamic analysis revealed that the behavior could be chaotic. So the result is not to be considered as a point of arrival, but a first step towards future research activity. Future developments are research the cause of the oscillatory behavior through the system variables, and to perform a more detailed chaotic analysis using additional measures and